Okay, everybody hear me okay? First of all, I apologize, I'm not a big presenter, so I'm probably gonna say things like a lot. You guys will have to bear with me. I'll do my best. There we go. My name's Roy Welch. I'm the batch plant manager and the QC lab manager here at Northwest Precast. This is Adam Whitehurst, quality control manager. We put together a presentation here for you guys, basically about the lessons we've learned over the past year and a half or so for producing UHPC. It's been a little bit of a journey. I've been with Tim for about a year and a half. Prior to that, I was at a Course Lab Structures in Phoenix. Before coming up here, I had never heard of UHPC, didn't know what this stuff was, didn't know what it was supposed to do, nothing. And then since I've been up here, we've managed, all of us together, to be able to kind of develop our own non-proprietary mix that we're kind of marketing now. Still working on it, but we're trying. And I just want to say to everybody that if I can figure out how to work with this stuff, anybody can. I am not the sharpest tool in the shed, so anybody can do this. Basically, we had a number of different resources in our journey learning about this stuff. Adam and I went to a UHPC symposium in Wilmington, Delaware. A bunch of really smart people. They have this every year, I think, somewhere in the world. I think it's in the States every 3 or 4 years. If you look into it, it's really great. All the world experts on UHPC are there. Everybody's very smart, and they all love sharing their information with everybody. Also, PCI's put out this guideline for the use of ultra-high performance concrete, which is really good. We have copies up here, limited amount. If anybody wants one, first come, first serve. When we're done, come up and grab one, please. A lot of good information in there. Got a lot of little tips and tricks and just overall information about the product. And then also, industry professionals. I've had the opportunity to talk with a number of different people. Anybody from Anthony at CNTech's had some great conversations with me. Other people doing testing and stuff with me. People like to talk about this. People that know about UHPC want to share their information with everybody. They want to grow this thing. So please reach out to anybody you know that knows about it, and they'll be more than happy to help you out. PCI's got some great resources, some webinars and stuff on there. I got some nice little tips and tricks and things from. And then there's been a ton of trial and error. We just over and over again have tried different things, whether it's placement, mixing, mix design, everything. We put a lot of time and stuff into this. We've broken everything up here into 7 different parts of the process for producing a UHPC component and getting it to a job site. Starting with formwork and then going all the way down through storage and shipment. One of the things we want to mention when we start talking about forms, okay, we're going to build a form for some UHPC. All of our other concrete here at Northwest Precast, if it's not UHPC, it's self-consolidating concrete. I'm sure most of you are at least familiar with it. It's a flowable concrete, 28-inch spreads, it's pretty wet. And so UHPC is similar to that in that it's self-leveling and moves. Also, I don't want to say like self-consolidating concrete, but when you're designing your forms and stuff, you know, if you've got like a vertical face and you're coming down to a flat part, it's going to run out of there and push everything up out of the way. So you got to keep in mind it's going to level itself and it's going to flow. Also, it's very impressionable. Both materials are really going to pick up any imperfections or anything in your form liner. A couple of the distinctions between these two things that we've noticed are that UHPC is a super dense, very viscous material. It's sluggish and it's heavy. It weighs a lot more. Typical unit weight when you're talking about SCC is probably somewhere between 140 and 146 pounds per cubic foot. And then UHPC is pretty much always north of 150 and then even up into like 170 per cubic foot. So that's a big difference there. And then UHPC has a higher paste content, and we've noticed that it can shrink just a little bit more than our other concrete. So basically you get into some of these caps and stuff and maybe blockouts, it can kind of grab a hold of them, and you've got to use some stuff to mitigate that. Another one of the things we've noticed with our form liners, when I talk about entrapped air with viscosity here, we had a project where we were using a broom finish form liner, and we noticed that due to the shallow nature of the broom finish in the form liner, it really kind of held on to the air. It didn't push it out as well as it might with a different concrete. So we had some bug hole issues there. So just something to keep in mind when you're choosing a form liner and stuff for this kind of product. We've ended up landing on a Noxcrete release agent that's a chemically active release agent for this stuff. Basically, when we first started testing and trying different things, we tried chemically reactive form releases, and we tried barrier form releases like different greases and waxes and stuff to try to just get the best finish that we could possible. The chemically reactive seems to work the best for us. Some of the instances where you might use a barrier are when you've got like a block out or something that you want to be able to easily remove from the material after you pour. We've noticed that if we apply like thick grease, it's easier to pull out of there after it cures overnight. Okay, so now we're under the impression that we've made a form and we're going to batch some UHPC to put in our form. And a couple of things we want to keep in mind before we even ever start the batching process is you basically got two options here. Everybody's either going with what they call a proprietary UHPC mix, which is going to come in like a pre-blend, which is what like Cientech sells. You're getting all your dry components already mixed up, and then it's going to come with some fiber and some admix and stuff, and then you're going to throw all that together. And then what we've been doing here lately is called a non-proprietary mix, which means we designed it ourselves. A couple of the distinctions here between proprietary and non-proprietary mixes, you've got a lot more individual constituents for your non-proprietary mix. So you're gonna wanna watch things like how much storage space you have, your ability to get things into the mixer. Some of the materials might have to be hand weighed, and you've got to make sure you have enough bins and stuff, you know, for all these different things to go into. I was just talking to Dan a little bit before the presentation about how he had like some limited space in terms of developing his own UHPC mix and not being able to get all these separate ingredients in there. Then with proprietary mixes, the great thing is it all comes in a bag already mixed for you, and then you just have to find a way to get it in there, right? So that's a nice thing. One of the things you kind of want to watch though, if you're getting like giant super sacks of it, you have to be careful whether or not how quick you're going to use the material. You know, it may not all go away right away. If you're holding it in a bin for a couple of days, it might want to set up on you and stuff. That's something you'd want to talk to your sales rep and stuff about, is the best option for you in that regard. Okay, so now we know, we decided what our mix design is going to be. We either developed it ourselves or we bought some stuff from somebody, and we want to talk about the mixer a little bit. Mixer type and speed. You'll find that the speed of the mixer can kind of help with your shear capacity overall, which is going to cause this stuff to break down a little bit quicker for you. You may not have a lot of control over that depending on what your resources are. So we've also found that getting your shoes nice and close to the floor of the mixer really can help a lot to increase that shear and have this stuff mix up quicker for you. Joe with Voller sent us over some synthetic mixer shoes that we're able to put all the way to the floor of the mixer. It pulls everything up, and then everything just comes together faster. So that's a thing that you kind of want to keep in mind for your mixer type. Once you start adding ingredients, we're going to be relying on a lot of visual cues to know when to do this. This isn't like a thing like your normal mix designs where you're going to put them in a computer and then just tell your computer go and it's going to put it in a set sequence every time the same time. You got to kind of watch it to know what to do next. Obviously with the proprietary mixes, your rep's going to help you with that. You buy some of these things from like Cientech, he's going to advise you on the best sequence to use to get all this stuff in your mixer. Another thing to keep in mind is that a lot of these things generate a lot of heat, and we want to control that temperature, so we use ice here in our mixes to make sure they don't get too hot. And forth to the convenience store buying ice before we just went ahead and bought an ice machine to be able to do that here ourselves. Batching, I've kind of broke down into 3 separate sections, the way I look at the whole process. In the initial sequence, you know, you're going to get all your sand and your cement and stuff in there, or in the case of proprietary, it'd be your premix. And we get that in there and you kind of let it mix around and fully incorporate, right? After that, when we start adding our water, I've noticed it's really helpful to put about 80% of that water in and hold a little of it back for later. It's going to kind of come in handy later in the process. I also put the majority of my super up front. I do split that in half as well. Just a couple of minutes in between both additions, I've found makes it work a little quicker for me. Once you get those chemicals and your cement and your sand and everything in there working together, what you're going to find, hopefully, is that things are going to kind of break down. And for those of you that came up and watched earlier, you see these spheres start to form. And what you'll end up with is this mixer full of like tiny balls that are kind of rolling around in a circle. And you're going to, you know, if you'd never seen it before, you'd look at it and think it's a mess and this is not what I want, this is horrible. But that's what you want. That's what this stuff is supposed to do. It's going to reach that phase and it's going to for a while. Then eventually those spheres are going to kind of form a solid mass. Once that solid mass starts to form and kind of move around the outside of your mixer, I found that it's really helpful to add my remaining water, which will cause it to kind of break down the rest of the way and reach this plastic state that we're kind of looking for, this fluid, continuous fluid state in the mixer. which takes us into the final part of the sequence. This is when we add our fiber. After the stuff is fluid, we throw all of our fiber in. We want to add it slowly. We want to make sure that it gets fully incorporated, like evenly dispersed. And then any additional admixtures will come after that. Like I think we add a hydration stabilizer at the very end. Once you've got it the way you want it, your fiber's fully incorporated. If you want to check it, we use a small brass grout cone and we spread it like we would SCC. You're looking for a spread. We can open up the mixer, drop a little bit out on the chute. We're typically looking for like a 9 to 11 inch spread here. We found works pretty well. If it's a little bit lower than you want, you can always add a little bit more super plasticizer or something into it to kind of get it where you want it. Okay, now we're under the impression we've got our mix together. It's the way we want it. It's the spread we want it, and we've got to get it to the bed. What we started with today, for those of you that were out here and saw, was we used a small Eimer mixer and we mixed up a little bit of this stuff and we put it in 5-gallon buckets and took it to the bed, and that's how we started here. When we first started doing projects, we didn't really have a good delivery system. We used 5-gallon buckets and dumped it in the components. Obviously that works, it's effective, it's very labor intensive, it's kind of tough. So you're eventually gonna find, I'm sure, that you're gonna graduate up to a larger receptacle. And then today for the rest of our stuff, standard precast bucket with a gate on the bottom. That's also effective. It can be a little bit troublesome because the stuff wants to get caught kind of in the gate, which isn't ideal. It's kind of hard to shut it off sometimes, which led us to kind of where we're headed next, which is where we purchased this grout hog. Tim and I were at the APA conference last year in Florida, and we went to Premier Precast, Gary and Dan's place down there, and we saw that they use a grout hog. Grout hog's great. It's got an auger in the bottom, and it's going to actually push the stuff out where you can get more of a continuous flow through a hose, and you've got more control over it. When Adam and I went to the UHPC symposium last year, we also saw that there's a lot of specialty equipment. We watched them laying down some paving, and they had this little specialty dump truck that was just built for hauling UHPC and dumping it on the ground. So there are companies out there that are making stuff all the time. You just got to kind of keep your ear to the ground and do your research, and you could find another option as well. Okay, we chose our bucket and we're headed over and we're going to place our product now. This is kind of, for an example, I just used a nice big flat slab, open top, kind of talking about how we would place it. We did some marine floats which were 1.5 inches thick, just open top flat slabs. Basically when you start pouring it, it's a lot like regular SCC. You want to watch that leading edge and make sure when you're adding concrete you're behind it and it's moving forward. It's going to move really slow. You can kind of get in there and slap it around and move it a little bit, which will help it along, or vibrate it even, but you have to be patient too. It's just going to go a little bit slower. After you've filled it, regular concrete, you're not going to be able to drag a screed across the top of it. It's going to bust it open and pull it and stuff like that. What you're going to want to see is just if it's level, so you just want to use a straight edge checking across the top to make sure there's no gaps or that it's not high. And then after that, with our picture of our elephant here, kind of shows it. What you'll see is a membrane form on the product. We call it the elephant skin, and it happens all the time on UHPC. What we noticed with our flat panels was that they tended to curl because of this membrane forming, and we found these. This is called a stipple roller, and it's spiked. You can find them online. What we found is right when that membrane starts, right when it starts to form, if we roll it out with this, it mitigates that curling effect. As soon as we were done rolling it, you just throw some plastic on it. If you don't put plastic on it to cure it and stuff, you're gonna notice like a little bit more shrinkage we found, which isn't great. So it's just a good idea to cover it up. Okay, we poured it, we've come in the next day. We wanna strip this stuff so we can pour more of it. So we're gonna kind of talk about what we have to do to get it out of the form a little bit here. Most of us, when we come in and strip our concrete, first thing we're gonna do is break a cylinder and see how strong it is, right? To get it out of the mold. You cannot just make a 4x8 cylinder out of this stuff and stick it in a compression machine and break it. It's not gonna work the same. There's a few different testing methods. What we found works really well are just 2-inch grout cubes. You can get those molds. And there's an example of them in the QC lab for anybody that wants to go in there and check them out later. And you can just perform the compressive strength test on the grout cube, and it'll tell you how strong it is. We found typically with this stuff, at least for us, it gets so strong and it gets strong pretty fast that we haven't had any problems with it being up the next day. As I talked about before, it can shrink a little bit more than our other mixes and stuff we've noticed. So for things like blockouts that you want to stay in your form and you don't want them to come out, you're gonna wanna make sure you take care with those to wrap them with some extra foam or like a nice barrier release or something to where it's gonna come out well. Inserts. I've kind of got an example here of like a typical sort of a precast tine that you might put in to strip a form. When we were doing these big planks and stuff, these were not engaging enough of the product to where we could pull it straight up out of there. So in-house, we kind of welded these on and developed this. These weren't available before we made them. And then of course, we sent these guys into ALP, I believe it was, and then they made a bunch of them for us and sent them back once we came up with the design. So I just say this because you can't really call somebody up and say, hey, give me some thin UHPC design components to be able to strip this stuff. A lot of it doesn't exist yet. So you might have to do some research and some work and kind of getting something that works. And then in addition to that, we discovered there are alternative methods. Sometimes they use like things, ways to get straps in them. Okay, for finishing, basically what we've tried to do here is apply the same finishes to this stuff. Got a couple of examples up here that we do to all of our other product, right? We're trying to hone it, we're trying to etch it, we want it to look pretty. This is a pretty good example if you guys can see, and I'm sure you've seen some other samples of the fiber that shows up in it. Stuff's got a lot of fiber in it, and it's gonna show, especially with like a darker concrete, you're gonna see it. It's light colored, it's gonna stand out. It's just one of the things you gotta kind of get used to with it. You can experiment a little bit with your design. I've noticed that when you have like a lighter paste and some darker aggregate, it mitigates it a little bit. You don't see it nearly as well. As far as sacking goes, we put that on there because when we were doing these broom finish panels for the marine floats, and we had the bug holes in them, we're trying to find a way to sack them, and we couldn't just go rub them out like we would a normal panel. What we ended up having to do was use a little bit of our super plasticizer actually in our sacking mixture, and then cover the whole thing with sacking and broom it out. So you might have to get creative in the way that you apply sacking if you find that you need to use it. Okay, once we have it finished and we have our product done, we want to store it in the yard before we ship it out. A couple of things to keep in mind. Really thin panels. We've talked to some people. There's a company in Canada that's doing like these 23-foot sunscreens, and they're only like an inch thick. And they originally said that they stored them flat, and what happened was they deformed because of creep. So then when they stood them back up again, they weren't straight anymore. So you might have to do with some of these things, obviously, is store them horizontally or vertically, depending on the shape and the size and the thickness. And then the same thing goes for shipping. You might have to have some specialty racks. You don't want to go through all the trouble to make this stuff, lay it down flat on a truck and have it go bouncing down the road and crack on you and stuff. So you have to take a little bit extra care sometimes in how you're going to ship it. A couple of general takeaways. You know, this is a new material for everybody. It's coming on pretty strong. A lot of people are asking questions about it. I think over the next few years, we're really going to see a lot of interest in it. Similar to the concrete you've been using maybe in certain regards, so you can kind of design forms the same way sometimes. It just depends. A lot of trial and error, right? Even if you're using a proprietary mix with advice and stuff that comes with it, you're going to have to try different things to see if it works out for you. And then the great thing to keep in mind is that through the APA and all these other like really smart individuals that are out there floating around in the market, that there's a lot of assistance out there. You know, you reach out to people, and I'll say it again, they love to talk about it. They love to tell you what they know about it. They love to talk about why it works, why it might not be working for you. So please feel free to reach out to everybody. And that's pretty much all I got, guys. Thanks for putting up with me, and thank you. We got any questions? There's talk about that. People that are talking about coming up with things that are kind of camouflaged in there. I don't think it's there yet, but I've heard that people are interested in it. Okay, I'll hand everything off to Tim then. Thanks, guys.
What do you mean you don't know how to do that?
You're a pretty good job, that's for sure. Okay, so
going to take a 15-minute break. There's some beverages back there, a bit of beer, wine. You can get up, and then we'll resume the second presentation, which is me. Thank you. Good job, bro.
Here you go, John.